So let's finish off the question in this video. We said we're going to calculate the utility now that they work as a team, and also the condition under which they work as a team. So first things first, what would be the utility function? Well, we know the utility for one guy, right? Either the first or the second is going to be the same because the function is symmetrical. Is the difference between the income, right? That's the benefit of working, get some income, and the cost of effort. Which is 1 over 2 theta e to the power of 2. So we will have 1 over 2 theta times e of the first guy to the power of 2. Now what is the income? Well, we calculated in the previous video, this is the income. So is the total value of the output that they produce divided by 2, and this is what we got as a result. So the utility of the first guy is going to be equal to the following. We will have p squared times beta squared divided by theta, p squared beta squared divided by theta, minus 1 over 2 times theta times e to the power of 2. So 1 over 2 times theta. What is the effort level? We calculate it over here as well. That's p times beta over theta. So p times beta over theta to the power of 2. Let's raise every term to the power of 2. This one, and this one. Now it's a matter of doing some math over here. So what can we do? We can cancel out theta with theta from here. And now we can solve. We have p squared beta squared over theta minus a half times p squared beta squared over theta. Notice we're subtracting the same term with different coefficients. The coefficient here is 1. The coefficient over here is minus 1 over 2. 1 minus a half is just a half. So that's 1 over 2 times the remaining, which is p squared beta squared over theta. P squared beta squared over theta. We calculated the utility function. Let's compare this utility function with the previous one because we will see something different. The utility in the previous video, when they were working by themselves, where was it? Over here, yes. So the utility in the previous part was just 1 over 2 p squared over theta. Now the utility is 1 over 2 p squared times beta squared over theta. So what changed is the beta, let me change colors for that. What changed, what's different, is the beta square coefficient, right? The utility function increased again due to this synergistic effect of working as a team. Now the last question is, when would we work as a team? Well, we care about ourselves, we care about our happiness, so we will work as a team if the utility from working as a team would be better than the utility of working individually. So basically we have to just compare these last two terms that we discussed about. This is the utility from working in a team, so we would write it as 1 over 2 times p squared times beta squared divided by theta must be greater than the alternative, and the alternative is just 1 over 2 p squared divided by theta. Now it's a matter of simple math to get rid of the common terms and see what this relationship must be. So 1 over 2 would go away, p squared with p squared would go away, theta with theta would go away. We're left here with a coefficient of 1 only. Beta squared must be greater than 1. If beta squared must be greater than 1, then beta must be greater than 1, right? By taking the square root of both sides. So if beta is greater than 1, we would work as a team. What's the intuition here? Beta is the team effect, is the effect from working with someone. So we must be incentivized, we must be motivated to work with someone, because as in return we would produce more, make more money, be more happy. So if that relationship holds, if that is at least the effect of working with someone else, we will accept it. If beta is less than this, right, we would still have a synergistic effect with working someone, but it would be too low to make us work with that person. Hope this all makes sense. And in the next video we go to part C.